All right, so now that you have a taste of what elasticity might look like, graphically, let's give the formal definition, so you can understand it in a more holistic manner. Okay. So in the previous slide, we demonstrated that demand was perfectly inelastic when there's a straight line because quantity demanded did not change with price. Okay. So we have our first type of elasticity, and this is the most common type. It's called price elasticity of demand. And that measures how quantity demanded changes with price, right? That makes sense. The price elasticity of demand, okay? And there will be others like price elasticity of supply, which should be pretty straightforward, how quantity supplied changes with price. Okay, but this is price elasticity of demand. This is how quantity demanded changes with price. In the previous one, we had perfectly inelastic price elasticity of demand. Okay, and when I say elasticity, generally speaking, I'm going to be talking about price elasticity of demand. That's the most common elasticity, basically by far, and the general one, so to speak, the default. Okay, but there are other types of elasticity, and the word elasticity in general just means how one variable changes in response to another. And then for the purpose of this class, how one economic variable changes in response to another. Okay. So you can think of elasticity like you do elastic clothing. That's where the term comes from, I would presume. Elastic means that it's able to change, it's flexible, and it can adapt as needed. Okay. So the more elastic the demand is, the more the quantity demanded changes as price changes. Compare that against a rigid or inelastic quantity price elasticity of demand. Quantity demanded does not change at all with price changes. Okay, so the more elastic, the more the change in quantity demanded. The less elastic, the less the change, the more rigid it is. Okay. So think of Joey's stretchy pants from Friends, right? He's wearing elastic pants to help him, adapt with the amount of food that he's eating, right? So the elastic is adaptable. Okay, the more elastic the curve is, the more adaptable you are, the more adaptable quantity demand it is. Okay. Okay, and then there's a simple formula, or I think it's fairly simple, but a pretty straightforward formula for how to calculate elasticity. Okay, so we use this subscript D for demand, price elasticity demand. So whenever you see this is an epsilon, this Greek letter, but the E looking drawn. Whenever you see the E looking thing with the subscript D, that stands for price elasticity of demand. Okay, and just like we said that elasticity is the change in quantity that arises from a change in price, so too we have elasticity of demand being the percent change in quantity divided by the percent change in price. This little triangle here that's called the delta. Okay, you should have seen this before in your math classes, I would hope. But the delta is just another way of saying percent change, or really just the change. Okay, so percent delta means percent change in quantity demanded over percent change in price. Okay. So to find the change in quantity demanded as a percent, we're going to take the new minus the old quantity demanded, and we're just going to divide it by the average quantity demanded. Okay. Same thing, the change in price is new minus old price, and then for it to become a percent change, we're going to take the average price. Okay. And we use the average price. That's just a rule that we use in Micro 1, basically so that the endpoints that you choose don't matter. Okay, whether you choose the change from going from P old to P new or P new to P old, it shouldn't matter which one is the old point and which one's the new equilibrium point. Okay, the P average will then make that the same. So how do you find P average? It's just the new plus old over 2. Okay, new plus old over 2 for quantity as well. Okay, so the new and the old are just the new and old equilibrium. So P new, Q new is the new equilibrium. P old, Q old is the old equilibrium. And what I was saying about averages is like, let's say we have a starting point over here, and we call this Q new, P new, and this is Q old, P old. Well, the average allows us to flip what's considered Q new, P new, and Q old, P old. Okay. If we took the same formula, but we put P new down here or P old down here, where P averages, then it will change the answer depending on what you consider new and what you consider the old equilibrium, which we don't want. We want a consistent elasticity no matter which one's the new and which one's the old equilibrium. Okay? And, let's say you were to take upper level microeconomic courses. There's a different formula that we use with calculus. So, that's more or less the standard formula. This is really the micro one formula. It's like an estimate formula. But when you use the calculus formula, you don't have to use the average. Okay, it's what's called a first derivative, but you don't have to worry about that. Okay. So let's do a calculation of elasticity. Okay. So we have a price change here and a quantity change here. All right. And I want you to solve this on Blackboard, and then we'll go over the answer. So let me just give you the formula again. Oh. I hope y'all didn't see that. I'm not going to edit this. So here's the formula. So just calculate it and see if you can get the right answer, even though I kind of just showed it a little bit. Do it yourself, please. Okay, let's stop.